Right, we're on. Okay. Right, we're on. Hello, everybody. Welcome to this lesson. Today's lesson is going to be about weld defects. But before we start on this lesson, I just want to go through a few house rules. Please keep your phones on silent or vibrate. Okay. Also, if there is a fire alarm, there's no fire drill scheduled for today. So we just go straight out the door, down the stairs, through the door at the bottom to the assembly point near the gate. Okay. Toilets, they're just behind you. There's two toilets there. There are drinks available to the rear. So you all have some experience of sorts in welding, haven't you? Yes? Yeah? Good. Okay. Has anybody got any questions before we start? No. Cool. Okay. If I ask you some questions, what I'll do is I'll pose the question to everybody and then nominate somebody to answer. Okay. Right. Before we actually start the lesson on defects, just a little bit of revision for you from last time. I'm just going to show you these particular welds and weld types and see if you can have a look at them, see what you think, and then just pass them across. I didn't weld it. Okay, just okay. Right. No. Say again. Yeah. Okay. Thank you. Thanks very much. Thank you. Okay, you've got four particular typical weld connection types there. This one, for instance, can anybody tell me what it's called, what type of weld it is?
How to say it in English?
Okay. Can you help him?
PA weld, that's right. This looks like a 6mm fillet weld.
Yes, a fillet weld. Okay, that's a fillet weld. Okay, right. So if that's a fillet weld, what do you think this one's called? Butt weld. Yeah. Don't try not to call out. Yeah. Okay, that's fine. And what do you think that one's called? Can you help him?
Wait a second. I will check.
Okay. Okay, it's a lap weld. Yeah. Okay. And the last one? No? Okay. Open corner. Open corner. Okay. All right. A little bit rusty, but that's fine. Right. What's okay. Can anybody tell me then, now moving into the lesson, why it's important to detect or find any defects in the fabrication phase before it goes out onto site?
So you know the welds are properly welded.
Yeah.
Welded, but laid out.
Yeah. Okay. What about yourself?
Like to less gas and the weld have defect, like the holes.
Yeah. Yeah. Okay. Porosity. Yeah. Well, basically speaking, you want to detect the defects before it goes out onto site, so there's no catastrophe on site and it doesn't fail on site. So if it's failing in the workshop, you correct it there before it actually gets delivered to site. Okay, yeah, all happy with that? Good. Right, we'll go into weld defects themselves then. Right, what we're going to do is identify the types of defects there are, the causes, and how to prevent them if we can. Right, a good weld. What does a good weld profile look like? Hopefully like this. This is a butt weld. Okay, it would just point out certain points that you need to look at to detect a decent weld. The actual reinforcement doesn't need to be too high or too low. It shouldn't be flush with the top of the parent metal. It should be slightly higher. Okay, The toe of the weld, which is there's no undercut or no overlap. It's sitting there nice and snug with the rest of the material. A good side fusion, you wouldn't see that unless you destroyed the weld to find it, but you'll see what we're talking about later on. The root penetration, if the gap's wide enough, you should have a decent penetration through the root, and you can see that through the bottom of the weld and the butt weld quite clearly. That's the root face. No blowholes or porosity. You're talking about porosity. Okay, right. The weld defects, they're categorized into different types. You've got cracks, cavities, solid inclusions, i.e. slag or material inclusions, lack of fusion and penetration, i.e. it's just sitting on the side of the walls. It's not actually bonded to the material itself. Imperfect shapes, i.e. different sized materials or different weird types of materials even, okay? And miscellaneous. Okay, we'll go through cracks. Right, there's two different types of cracks, hot cracks and cold cracks. Generally speaking, it's a lot of heat you've induced into the material itself, and as it shrinks and the material stays where it is, as the weld shrinks, it's got a tendency to crack because there's too much weld material into the actual weld. Also, sometimes the parent metal's got phosphorus in it or sulfur, and that will include into the weld and cause it to crack. Hardened heat affected zone. The heat affected zone is where between the weld and the actual parent metal here, where it's actually darkened, where the heat has affected the steel, the actual, and that can harden up, especially if it's got high carbon content or something like that in it, and it will harden or case harden. Okay, so susceptibility means it's susceptible, or it can happen with an increase in the thickness of the material, or especially with extra high carbon in the material. The tendency is that you've got a softer material attacking it, which pulls in and shrinks and pulls the parent metal and cracks it because it's brittle. It can also occur in the weld material if the weld material's got some defects in it as well, if it's not quite the same as the parent metal. Preheat is sometimes necessary, so you preheat the parent metal so it brings it up to sort of a decent temperature, so when it does shrink, it all shrinks in the same sort of level. Control any moisture in your consumables if you're using welding rods or welding wire. Make sure it's dry. And clean the weld. That's really, really important that you keep the weld, before you weld it, clean it back, grind it back, get rid of any sort of dross, anything in there. Okay, this is what can cause slag or sharp inclusions. Okay, and what this generally is either slag from an electrode or slag from the parent metal when it's been rusty and it's got pieces in there when you've done a run, a weld run, and it'll basically capture inside the weld and cause a defect. Porosity, it should be up to 1.6 millimeters, no more. If it's any more than that, it's a defect and you have to dig the weld back out and re-weld it. Okay. Porosity is groups of holes through, and it's caused through dampness, it's caused through rapid cooling, and it's also caused through the gas, lack of gas, where the CO2 can get involved with it. And it looks like that on the surface. Extensive reinforcement over the top there, it's crowning too much, okay, and that can cause a defect. It's a round defect. I mean, there are several answers to that: grind it back and all the rest of it, or dig it out and re-weld it properly. But it's poor technique. It's too much, too slow a travel. Okay, too large an electrode for the joint. Okay, so that's basically what it is. You're just pouring too much in there. Right, lack of penetration. Incorrect edge prep, okay? Basically, you haven't got rid of all the rubbish and the slag inside there. It's still picking up rubbish, and it's not penetrating into the sidewalls, and it's not going through to the bottom. Also, you should always leave a gap at the bottom. If you're not left enough gap, you're not going to get the penetration through to the bottom anyway. Incorrect weld technique, that's fairly obvious, okay? Inadequate deslag, say it needs to be cleaned off because the slag will stop it from penetrating to the sidewalls. Okay, this again, you can see there is a heat affected zone there. So that's what it's showing you there. It's not gone through to the root. Okay. Excessive penetration, that's the other way around, basically a too wide a gap, or there you go, too big a heat concentration, or basically you've dug it right out when you ground it right down to the bottom, and there's not enough, it's just no material for it to actually burn to, it's just gone straight through the bottom of it. Incorrect edge prep and too slow travel. Anybody got any questions so far? Okay, good. Right. Okay, lack of fusion again, insufficient heat. It's not your actual welder's not hot enough. It's too fast to travel. You need to slow it down. Make sure that you're actually getting the amps and getting into the parent metal. You can see there's a severe lack of fusion on this side. Okay, that one's a little bit better, but still not as good. But there's no penetration there at all. And same again there. You can see here and there. Okay. And that's lack of fusion. It's just not there. It's just not hot enough. And cold lap again. Once a similar sort of thing. Your technique's wrong. It's going into here, and it's just sitting on top of the actual material. Insufficient heat. Welding current's too low. Contamination of the surface of the metal. Okay, and bad welding technique. So your angle's wrong and your speed's wrong. This is the opposite side of the spectrum. Now you're going too hot. You're too hot and you're too fast, okay, which is undercut. Too fast to travel, okay, too great a buildup of your heat, and it looks like that. It just burns the parent metal away either side of the weld. The same thing with burning the hole out at the bottom. When you're actually putting a root run through and you're burning the bottom out, you're either going too hot or you've just dug out too much when you ground it. Poor edge prep, too great a heat concentration. The speed of your travel is too slow. Okay, so it's putting heat in there too much. All right. Incorrect leg length, that means your angle's wrong. And that's one leg's longer than the other. That's what it's showing you there. Poor position, wrong electrode torch angle. Okay. The crater, that's towards the end of your run. Incorrect manipulation. Basically, you haven't stopped and waited, let it cool down. You've just come off it and let it just cool on its own, and it's created a crater. It's shrunk as it's... Okay, your miscellaneous ones, these are straightforward. Grinding, chipping. Okay, so that's basically when you've got at it with a grinder and you've attacked the weld and you've defected the weld. Hitting it with a hammer. Torn surface. Okay, so they're just showing you all of a sudden you've had a stray arc strike. That actually is counted as a defect, especially if it's a structural piece of steel. Okay, and spatter. You always clean your spatter up. Right. Anybody got any questions on any of that at all?
No.
Okay. Okay. Thanks ever so much. Then there's a questionnaire there. You'd like to fill your questionnaire in. Okay. Your answers should be in here, but I have actually covered it on there. So if you just fill in the questions, fill in the answers. Okay. Let me know you got. And if you've got any questions about it, stick your hand up and I'll try and help. Okay, brilliant. Thank you. Yeah, great stuff. Perfect. Thank you very much. Thank you. Yeah, no, thanks very much. Thank you. Don't disappear just yet. No, thanks a lot. Thank you for that. Okay. Thanks ever so much for your attention. Your next lesson will be about distortion and how to stop that from happening. Okay, thanks for your time. Thank you.
Thank you very much.